correct?
Yes, you can bring your own calculator, and it just needs to be a scientific calculator. So if you only have a graphing calculator, right, or your cell phone, obviously, you won't be able to use those in there. It needs to be a scientific calculator, or even just a regular, just like a 4-function calculator. But if you have one, you can use it. They'll let you know if it's, if you can use it or not, if you're not sure. And if you can't, they do have scientific calculators they'll lend you.
Perfect. Thank you.
Yeah, so 17 questions, 90 minutes. It really should be plenty of time to get that taken in and be able to hopefully go back and, check any answers or anything too. That's my hope on that. Other questions that you've been thinking about that you'd like to know about the exam? Because I know, like, first exam, it's always like, what to expect on this? So. All right, well, if you think of some as we go along, please just unmute yourself and ask away, because I do want to make sure, let's see, there are some people that are in the chat. Look and check that. Okay. Yep, there we go. All right, so let me share my screen and we'll get started on this. Oops, that's not the one I wanted. Okay, so hopefully everybody can see that. All right. Let's see here. Okay, let's start off with some questions that I like to go through. Usually these are problems that tend to show up on the exam, and are also ones that some of these are ones that students kind of struggle with on the exam. But I also want you to, give me any questions that you have, like if you had some problem with any of them, in the homework or the quiz, and you just want to make sure you're doing them right before the exam, that's great. We'll go through those as well. Okay. All right, so let's get started on this. So the first one I'd like to look at is when we're solving an equation with decimals in it. Okay, so if it asks you to solve 0.45x minus 2.04 equals 0.7x plus 0.36. All right, so in the videos and in the book, it told you that you could go through and clear the decimals on this, and that is a way that you can do this. However, you don't have to. It's just one way that you can do it. And usually when I'm working with decimals, I don't clear the decimals. Like on this one, I'd have to multiply everything by 100. And the reason why I don't is just I know I'm going to be using my calculator anyway, and so it's just not, there doesn't seem to be much of a difference for me if I use the calculator on that, like if I need to clear them or not. So, all right, so on this, we want to get the x's on the same side, so I'm going to start by subtracting that 0.7x over. And when I do that, I get negative 0.25, right? Because I have to do if you put it in your calculator, 0.45 minus 0.7, okay? And then let's add, I need the whole numbers on the other side, so let's add 2.04 over. And when I do that, right, I end up here with 2.40. Let's bring it over there. Should have been underneath here, but oops, and I forgot my x on this, right? If it has an x, I have to combine those together, and I need that x on the answer. And then the last thing to do, the negative 0.25 is connected to x by multiplication, right? So when something's connected by multiplication, we'll divide by that. So divide by negative 0.25. And so when I do that, I get, right, that just becomes a 1. Those divide out, and so I'm just left with 1x equals, and then put in your calculator, 2.4 divided by negative 0.25. And then what do you guys come up with there?
Negative 9.6.
Yeah, negative 9.6. Okay, now, on some of the questions, it might ask you to check your answer. So I want to make sure you guys know how to, check your answer on this. So can somebody tell me, how could I check that negative 9.6 is correct?
You replace the x with negative 9.6
Yeah, so everywhere
and multiply those.
Yeah, so we're going to go back to the original problem there. It's always best to go back to the original. When you get into higher math classes, it will really make a difference when you do that. So let's just get in the habit of putting it into that original equation. So like you said, in place of x, I'm going to put my negative 9.6. So I'm going to have 0.45 times negative 9.6 minus 2.04 equals 0.7x, and the x is going to be replaced with negative 9.6, and then, oops, I'm running out of space here, plus 0.36. Okay. And so then I just need to do some multiplying here to get those together. So let's do that really quick. Again, we can use our calculators, so use those to help you out in any way that you need to. So if I multiply these two together first, I get negative 4.32 minus 2.04. And now if I multiply 0.7 by negative 9.6, I get negative 6.72, and then I need to add 0.36 to it. Now remember, with the check, what we're trying to check to see is, does each side equal the same thing, right? So we've got to get the same thing on both sides since it's an equation. So let's just, while we're here on this side, and I have in my calculator already that negative 6.72, so I'm just going to add 0.36 to that, and then I end up with, oh goodness, I keep losing this, negative 6.36. And then when I combine on the left side together, negative 4.32 minus 2.04, I also get negative, keep losing my little cursor here. Hold on a second. All right, well, where is my cursor? Okay, here we go. Okay, so since those are the same thing on both sides, and that does check out, and we know for sure this is our answer. Okay, now I suggest, like I said, you're going to have more time on this exam than you might need. So I highly suggest that, after you've solved all of them, all of the questions on the exam, maybe then go back and do these checks. Although, like I said, on some of the questions, it might ask for that. So this will be required on some of the questions. So make sure you watch for that. But it's a good idea to do on any of them. Okay. All right. Any questions on that? Maybe I'll just number these so we go through. Okay, so let's do another solve question. And the other one that students sometimes struggle with is if there's fractions in it. So this one's going to have the fractions. So this one's going to say 2/5 times y minus 3 equals 1/2 y. All right, and this is really similar to what you had on that reality check. And so those of you that noticed with the reality check, what they did wrong here, that thing that they did wrong tends to be what happens to most students on the test if they miss this. Okay, so most students remember, okay, I've got to find the LCM, right, the least common multiple of the denominators. And so my denominators are 5, 1, and 2. And so my LCM of that is going to be 10. All right. Now you can just multiply the numbers together to get that. It wouldn't always be the least common multiple, but it will be a common multiple. And so that usually can work out for you too, to do that as well. All right, so, but the other way to find that is list out the multiples of 5, list out the multiples of 2, and then whichever number is the first one that they have in common. So 2, 4, 6, 8, 10. All right, and then I can see, all right, this is the smallest number that both of them have in common. So that's how you can find out the least common multiple. All right, and so then we take that and we want to kill off the denominators here. And, working with fractions, oftentimes for most people, they just haven't made fractions their friends yet. And so if we can get rid of them, then it's just going to make it easier for you to do. All right, so we need to multiply every single part by 10. And so this one, the 3, that -3 there is the term that students usually forget to multiply the LCM by. So make sure you remember you got to multiply it by every single part. Okay, and then there's a couple of different ways that you can simplify this. For some students, they'll, kind of cross things out first and then do it, or you can just multiply across the top and across the bottom, right? So here I got 10 times 2 is 20, and then over 1 times 5 is 5, and I need my y there, and then minus 3 times 10 is 30, and then I really just have 1 on the bottom there, right? So I don't need to do anything really with that, but I'll keep it there for right now. And then on this last one, 1 times 10 is 10, and 2 times 1 is 2. And because remember, when you multiply fractions together, you multiply across the top, multiply across the bottom. But if you want to reduce it first, you're totally good to do that. I'm just showing you one way you can do this. Okay, but now if I simplify this, 20 divided by 5 is 4, so I have 4y minus 30 equals 10 divided by 2 is 5, so I have 5y. All right, and now I have no denominators left. There are no longer fractions, and so it makes it a lot easier to solve this. And then I just need to get the y's on the same side, so I'm going to choose to subtract my 4y over to the left side, and 5 minus 4 just gives me 1y, and I'm left with negative 30 on that side. So y equals negative 30 would be my answer on this. And again, you can check this just like we did on this first one, right? Replace your y with negative 30 and then simplify and see if you get the same thing on both sides. Okay, but always go back to that original question. All right, what questions do you have there on number 2 with those fractions? Like I said, sometimes that is a little tricky.
I don't know how to phrase this as a question,
Okay.
but I solved it a different way and got the same answer.
Whatever way you want to solve it, as long as you're showing your work, is totally fine with me.
Okay, perfect.
So I'm not gonna, say, oh, you have to do it, a specific way. There's nothing on this first exam where you have to, solve things a specific way. On our next exam, we will have some like that, just because we'll have different methods, and I want to test you on those different methods. So, yeah, if you, did it differently, and I'm sure you're not alone, I'm sure other people are like, yeah, I know another way to do that. That's great. As long as you show your work on it, I love it. Okay, let's do another one here. And again, if you have questions that come up, please ask, or if, we go through one of them and it kind of jogs your memory of like going, oh yeah, I had a question on that when I did the quiz. Okay, this one's a story problem, and so I want to make sure that we do one like this. Okay, it says a student has scores of, I'm just going to write these down. Wow, this keeps jumping around. 92, 81, and 86 on their first 3 exams. What is the minimum score they can get on the 4th exam to get at least an 87% in the class? Oops. Okay, so really this is a question where we are doing an average, but it also is one where we're using some inequalities, okay? So if I'm looking at this, so these are the 3 test scores that I'm given, all right? So I know I'm going to add those together. So I'm going to have 92 plus 81 plus 86. But then what I don't know is what I need to get, or what the student needs to get on the 4th exam. So X is going to be defined by the score on 4th exam. All right, so it's always good to kind of define your variables, what you're saying these are. And so then I need to add that to it. All right, whatever that is. I don't know what that is yet. I'm going to solve for it. But when I am taking an average, I add all the numbers up and then divide by how many there are. And so after I take that 4th exam, there will be 4. So I need to divide these all by 4. Okay. And then I want to know, the minimum that they can get on this. So they need at least an 87. So that means that they need that to be greater than or equal to 87. Right? Because if they get an 88 in the class, or an 89 or a 90, they'll be perfectly fine with that. They just want to make sure that they're above an 87. Okay, what will we do from here to solve it? Can somebody tell me what you think you would do next?
I like to combine the terms on top.
Yeah, let's add those together. So Add 92 plus 81 plus 86. What do we get?
259.
Okay, so 259 plus x over 4. It needs to be greater than or equal to 87. Okay, what would be a good next step?
Timesing both sides by 4
Yeah, why are you going to times by 4 on this?
to take away the fraction.
Yeah, we want to get rid of that fraction, and we're dividing by 4, so to undo that, we'll multiply by 4. And then that will be gone, right? So on the left side, I'll be left with 259 plus x is greater than or equal to, what's 87 times 4?
348.
Okay, 348. And then what's left to do?
Subtract.
Yep, let's subtract that 259 over, because we're just trying to get x by itself. All right, so then x needs to be greater than or equal to what?
89.
89. Awesome. Okay, and so when we're thinking of this, remember that when we have word problems need word answers. And so you need to make sure that and the reason why I say that is because it helps you make sense of the problem, and to make sure that, that you go, oh, does that make sense or not? Because what if you came up with a negative 89? And you're like, well, wait a minute, I can't end up with it. She can't have a negative score on her exam. That would be really awful if you could get a negative score on an exam, right? So you'd want to think, oh, okay, I need to look back through that again. So I'm just going to put out to the side. So 89 or better on 4th exam. Something like that. Just put in words what you're doing, or needs, or something like that. Okay. All right. Let's keep going. Let's get a few others here. Okay. So sometimes on this one, there's just percent problems. Make sure that you know how to do. So 10.54 is what percent of 85? And there's a couple of different ways that you can set this up. You could set it up in equation form, just reading this, like translating this English sentence into a math sentence. All right, and so if I do that, okay, I've got 10.54 is, in math, means equals, so we'll put equals. What percent, that's what we don't know, so maybe I'm going to call that my variable x. And sometimes when I'm finding the percent, I like to put the little percent symbol there just to remind me that I need to have my answer as a percent when I write my final answer down. Of in math means multiply, so times, and then 85. All right, so I can directly translate that to be able to do this. Okay, or you could set it up as a proportion. Some students like to do it that way as well. But if we solve for x here on this one, we just need to divide by 85. All right, because right now it's connected by multiply. So if we divide by 85, so put in your calculator, what is 10.54 divided by 85?
0.124.
Yeah, so 0.124, but this isn't written as a percent, right? And we want to make sure our answer is written as a percent. So we need to either multiply that by 100, but when we multiply by 100, what it really does is moves that decimal place 2 places to the right. And so that would give us 12.4%. Right? And that would be your answer. So make sure you remember your labels on it like this. If there's, something that you need like inches or feet or percent or dollar sign, make sure you remember those labels as well on the exam. Okay. All right, questions? Like I said, any way that you've been working on doing them that you like, that works for your brain, use it, right? I don't want you to think that you have to solve these problems in any specific way, as you don't. Whatever works best for you. Okay, let's try this one. On this one, I want you to solve for r. All right, so we're trying to isolate one of the variables in an equation. So this one says r times t plus w equals 7b. So we're trying to get r by itself. What would be a good first step in this?
Wouldn't you subtract W?
Yes, right? And if you get, confused by it because there's just all of these letters in it, right? I mean, think about it if it was, just an equation like you've usually done, right? If we had something like this, right? 3t plus 4 equals 7. Yeah, you'd take that 4 and minus it over, right? And then you'd go from there, okay? So it's still the same idea. So now we have r times t equals 7b minus w. And then we want r by itself, and it's connected to t by multiplication. So let's divide both sides by t. And so then you'll have r equals 7b minus w all divided by t. All right, and make sure you put it all over t, or you show both of them divided by t. It's, sometimes students will accidentally just like put it underneath the 7b and not the whole thing, and that means something different. So the whole thing needs to be divided by t there. Questions on that one?
Nope, not now.
Okay. All right, let's get into some of the absolute value stuff because that tends to be where we have some questions on this. So with absolute value, when you're solving absolute value equations, I want you to remember that you're going to always have two answers. I'm going to write that down here. Okay, we'll have two answers when solving absolute value equations. And I'm pointing this out because, again, that's what I see as probably the biggest mistake that's made on this, or the most common mistake. All right, so here is the question that I'm going to solve. So on this one, I want you to just solve. Excuse me. All right, let's do the absolute value of x minus 8 equals 12. Okay, now when you're solving absolute value equations, you want to make sure that that absolute value part is by itself. So if there's anything out in front that's being multiplied by it, you need to divide that over first, and so on. So make sure you always remember to isolate that absolute value part. And then once you've done that, now you can write your two different statements that will give you the two different answers, right? So the first one is going to be just the way this is without the absolute value bars. So x minus 8 equals 12. And then the other one, take it out of the absolute value bars. X minus 8 equals the opposite of 12, or negative 12. Okay. And then we just need to get the x's by themselves. So here, let's add the 8 over. And 12 plus 8 is 20, so x equals 20. And then here we're going to add the 8 over, and then x equals negative 4. Okay, so we ended up with two solutions there. Now, on some of the videos on this second equation, they sometimes show you to, distribute the negative number here on the left side. And if they did that, then you would have negative x plus 8, right? You have to change both of those signs. And then you would leave this on the right side alone. And so I don't like doing this because there's just so, it's just easy to forget to change one of those signs. But it's totally a good way to do it if you like that way better. But if you can just remember to, keep the right side, the same on the first one, change the right side to its opposite on the second one, then you'll be all set. Okay? Not doing anything with the stuff that's inside the absolute value bars. Okay, so there are our two answers for that, which is what we were expecting to get on it. Okay. Let's see here. I'm going to try maybe another one here. Let's do an absolute value inequality one. Okay. So if I have actually, I'm gonna do some of these and or statements first, because I'll come back to that idea here in a second. Okay, sorry. Let's try doing some of these and or statements, these compound inequalities. So on this one, we're actually going to solve, graph, and write our answer in interval notation. Okay, and so when I do that, let's see, I have 3x plus 5 is less than negative 13, or negative 2x plus 5 is less than or equal to 7. Okay, so what does this or mean?
Union.
Yeah, it's the union. And so that means we want everything that is, part of this statement as well as this one. We're saying it could be in either or of these. So let's solve them first, and then when we graph them, it's easier to kind of see what our answer will be. So here, let's start off by subtracting the 5 over. So I get 3x is less than negative 18. And then to get x by itself, I need to divide by 3. So x is less than negative 6. Now let's solve this one over here. We'll start by subtracting 5 over. Negative 2x is less than or equal to 7 minus 5, which is 2. And now we need to divide by a negative 2. What happens when we divide by a negative?
Switch the sign.
Yeah, that sign, that inequality sign, has to flip the other way. So I'm going to put it in red just to make sure it kind of stands out, right? It was less than or equal to, but because we divided by a negative, we got to flip that sign the other way. And so 2 divided by negative 2 is negative 1. And now I need to just graph these on the number line. Right, so I'm going to have -6 somewhere down this way and -1 here. Right, make sure this is a number line we're making, so as the numbers get further and further to the left, they get smaller and smaller. Right, and then I'm just going to do these in 2 different colors just so maybe they stand out. I'll do this first one in blue. So x is less than -6. Well, it is a less than, not a less than or equal to, so that means there's an open circle at -6. And then we want all this stuff less than, I kind of think of this as an arrow pointing to the left, and so it's all of the numbers that are smaller than -6. And then on our other one, graph this one in green, x is greater than or equal to -1. So since it has the equal to part, I need to have a closed-in circle, and we want everything bigger than -1, so that would be everything to the right. Okay, and again, that kind of, it looks like an arrow pointing to the right. That only works, like the arrow trick only works if you've solved to get that variable on the left side. I highly recommend that you do that. Always solve them to get on the left side, just so that you're reading that inequality forward. Otherwise, you're kind of having to read it backwards. It's not wrong if you do it the other way. It just sometimes is easier to make some mistakes. Okay, and then our answer on this, since we're looking for the union, that means that we want everywhere the blue graph showed up and everywhere the green graph showed up. So that means this is going out to -infinity. So I'm going to say -infinity to -6, but it doesn't include -6, so I'll use a parenthesis. And then the little u saying, okay, that's not all. All right, we're skipping some numbers in here. And then we want everything -1 and bigger, so -1 to infinity. And that would be our answer.
Wouldn't the parenthesis on the -1 be the bracket?
It is the bracket. I think I said that and then I didn't do it. Thank you so much. Right? I said it's included, so we need this. Thank you so much. Awesome. Okay, and it's so easy to make those little mistakes, so always just double check yourself, right, on that. Okay. All right, let's do another one. This one we'll do an and statement, just to make sure we solve one of each. So this one I have 2 times 3x plus 4 plus 6 is less than or equal to 44. And 3x is less than 4x plus 1. Okay, so let's go ahead and solve this one. I see we have parentheses here, so we do need to start by distributing that through. Be a good first step. So 2 times 3x is 6x, 2 times 4 is 8, and then we still have this plus 6 is less than or equal to 44. Okay, now I see I have some like terms I can combine together, so I'm going to do that. So 6x, and then the 8 plus the 6 is 14. All right, it's still less than or equal to 44. I'm trying to get x by itself, so let's subtract that 14 over first. So 6x is less than or equal to 44 minus 14 is going to give us 30. And then we need to divide both sides by 6. And when I do that, these 6's divide out, leaving just x, which is what I want. X is less than or equal to 30 divided by 6, which is 5. Okay, so there's one of them that I need, right? And then I'll have this and statement that I'm looking for here. And when I'm dealing with an and statement, what is it? Like, what am I looking for when I have an and statement?
Intersection.
Yep, I want the intersection. And the intersection means that I want the overlap. on the graph, right? So that's what we're looking for here. Okay, on this next one, some of you may, think that you want to subtract the 3x over to the right side just because 4x is bigger, okay? And you definitely can do it that way. But I just got done saying on the one above, like I like to get everything over to the left side just so that I'm reading my inequality forward. So I'm going to do it that way, but I'll show you the other way as well if you'd like. So I'm going to choose to subtract 4x over here. So when I do that, I end up with a negative 1x is less than positive 1. And then I need to get x by itself here, and it's not by itself because I have a negative 1. So I need to divide by negative 1, and then I'll have x. And then since I divided by a negative, I've got to flip that inequality sign again. So x is greater than 1 divided by negative 1 is negative 1. All right, so if we did it, this way, moving everything over to the left side, we get that. Let me just show you up here if we did it the other way, because I want to show you what I mean by reading it backwards. All right, so if I chose to subtract my 3x this way, all right, then I end up here with 0 is less than x plus 1, and then I need to subtract that 1 over. So I end up with negative 1 is less than x. All right, and here we had x is greater than negative 1. These are equivalent statements. They are saying the same thing because you have to read this backwards. And so here we're saying x, and now, because of the way it's opening up, right, that's going to be greater than negative 1. And so that's why I say, like, it gets kind of confusing for some students. So it's just easier to just have that x always on the left side, then you don't have to worry about it. Okay, so we're going to graph these two on the same number line, and then we'll see where they overlap. So I've got negative 1 over this way, 5 is bigger than it, so it'll be somewhere down here to the right. Okay, so then in green, x is less than or equal to 5, so at 5, I need a solid, a closed-in circle, filled-in circle, because I have that equal to part. And then I want all the stuff that is smaller than it. So that's going to be all of the stuff going to the left. Okay, now let's look at the other one. X is greater than negative 1. So I have an open circle at negative 1. And then everything bigger than it. That way. And again, I want to look and see what I have. Okay, it's the and statement. So that means I need the overlap. And so these are overlapping between negative 1 and 5, but also including 5. So if I write that down in interval notation, and interval notation always needs to be written from left to right, from smallest to biggest. So I'll start off with negative 1 to 5, and since it's a closed-in circle, we'll use a bracket on that, and then that is my answer in interval notation. Okay, so most of these will say solve, graph, write your answer in interval notation. Okay, anything I can clarify better for you, help you understand better on those and or statements?
So with the or statement, if in an instance they are overlapping, going opposite directions, that would instance a negative infinity, comma infinity, correct?
That's correct. Yep. So if you had, let's see, I'll just draw something out over here, right? So let's say that you had, some numbers here. You had this one going this way, and then you had this one going this way. And it's an or statement, right? So if it has an or statement, we're not looking for the overlap on that. We're saying everywhere the green graph appears and the red graph, so that would be everything, negative infinity to infinity, all real numbers, okay, on that. And kind of, along with that, if you had an and statement where they weren't overlapping, then that would be the empty set or no solution, or DNE, so you have you put it on the homework. All right, so you can't end up with some of those answers, either negative infinity to infinity, or you could have a no solution. Thank you for asking that question. All right, let's do this inequality, this absolute value inequality now, just because I want to make sure we do one like this. Okay, so again on this, we're trying to solve, and I've got absolute value of 3x plus 8 is greater than 1. Excuse me. Okay, so our absolute value part is by itself already. If it isn't, make sure you get it by itself before you make your two statements. All right, so I'm going to make my two statements again like I did before. And so this first one is going to be just the same, right? 3x plus 8 is greater than 1, just doesn't have the absolute value bar. What is my second statement going to be?
3x plus 8 less than minus 1.
Yep, less than -1, right? So we had to flip the inequality here and change that sign to its opposite. All right, you have to do both of those things. So make sure you remember to do both of those. All right, so let's go ahead and solve these down. Subtract the 8 over. We get 3x is greater than -7. And I'll divide by 3. So x is greater than -7/3. Okay, and then here I'm going to subtract my 8 over. And so I get 3x is less than -9. And divide both sides by 3. X is less than -3. Okay, but this statement in our question, so once we have that absolute value part by itself, whatever our inequality is there is going to tell us whether we have an and or an or statement, if we're looking for the intersection or if we're looking for the union. So if you watched my video that I did before, I gave a couple of different things that just a silly way, I guess, to help you remember things. So if we have a less than or equal to, I want you to think of this as less than, right? It's an and statement. But if you have a greater than or equal to, then I want you to think of it as greater, right? And so just a way to just help you, remember which one's which. So this one, we have a greater than symbol, so that means that it's an or statement, so we're looking for the union on this, right? Which means we want everywhere those graphs show up. Okay. Now, -7/3, you might want to change it to a mixed number just so you know where that's at on the number line. That sometimes can be helpful. All right. So if I did that, right, 3 divides into 7 2 times with 1 left over. So that's the same thing as -1 2/3. So -3 is the furthest to the left here, and then I'd have -2 1/3 there, but if you want to keep it as -7/3, you can. That's just helping us to know which way it should be on the number line. Okay. All right, and now let's just graph these. You can see, so greater than the -7/3, right? All the stuff greater than it. Open circle, all the stuff to the left. And then we have x is less than -3. So -3 again has an open circle on it. Stuff less than it is this way. Okay, so what will my answer be on this? Remember, it's an or statement. So what are we looking for?
So with the negative 7/3 being less than x, wouldn't the arrows be going the other way?
I'm not sure I'm seeing what you mean.
So like with negative 7/3 x going to the left, wouldn't it actually be going to the right and then -3 be going to the left?
Oh, wait a minute. Did I put those backwards? I think I said greater than. I said less than there, didn't I? Oh my goodness. What is up with me? Okay, let me see. Let me get those changed.
Definitely confused for a second.
I know. I'm sorry. That would be
You're good.
confusing. Okay, so let's look at this again. So here is our number line. And so we're saying, okay, greater than negative 7/3. We want it this way. And less than -3. We want all the numbers this way. Okay, that looks better. Okay, then how would we write our answer?
Do a negative infinity, -3 is a union with negative 7/3 to infinity.
Yep, and both of those would be parentheses, right? Because they're open circles there. So that's how you'd write it. If it had the equal to part, then we'd want squared brackets on both of those. And if it was the other way where they were crossing over each other and it was an or statement, that would have been like we were talking about above, negative infinity to infinity. But yeah, that was my mistake. I am so sorry. Feeling a little tired today. I don't know if it's the weather or what.
It is a Monday.
It is a Monday. And it's kind of dreary where I am, so.
So then so the only time we use the brackets is if it's the greater than or equal to signs?
Yeah, if it has the equal to
Okay, 'cause
part.
That's what I was getting like mixed up with.
Yeah.
So
Yeah, so the only time you're going to use the brackets is if you have that greater than or equal to or less than or equal to. Yep.
Okay.
Okay. I think that might be it. Let me just look through this again and see if there's anything else I wanted to go over with you. I mean, we could look at a couple more story problems if you want to. I can probably stay on, a few more minutes. Were there any story problems that you guys were struggling with that you might want to go over?
can we do on the review like ones like number 25?
Yeah, what does it say?
It's 1/3 is the absolute value of x plus 4 equals 2.
Okay, 1/3 times the absolute value of what?
X plus 4
Okay.
equals 2.
Okay. Yeah. So with this 1/3, that's what usually people are like, what do I do with that? All right. Well, you can multiply by the reciprocal, which would be meaning that you're multiplying both sides by 3. So that's what you need to do first, because you got to get the absolute value part by itself. And timesing by 1/3, I mean, think about this. I'll put it kind of over here. If I have 1/3 times the absolute value of x plus 4, it's kind of like there's a 1 underneath it, right? So really, I could write this as the absolute value of x plus 4 all over 3. And then sometimes people are like, oh yeah, I can see that it's being divided by 3. And so that means I need to multiply by 3 in order to get rid of that. So sometimes it's just the way it's written there, this 1/3, right, tends to be a little bit tricky with it, but what you need to do is multiply that by 3. And so that would leave us with absolute value of x plus 4 equals 6, and then I can write my 2 statements from there. Is that the part that was that you were wondering about? Was just that 1/3?
Yes.
Okay. Yep. So really the rest of this is going to be kind of the same as the other one. Right. So we'll subtract 4 here, get 2, and subtract 4 on this one and get -10. Okay, but again, absolute value equations will always end up with 2 answers. Make sure you remember that. Good question. What other ones? Are there any reviews or?
Could we do an example of the, what is it called, set builder notation?
Yeah, there's not going to be any questions that ask you to write it in set builder. Does that help?
Yes.
Okay.
Perfect.
So all of the questions are going to ask you to put it in interval notation. Okay, glad you asked that.
Thank you.
Yeah. Anything else?
What would make an equation a no solution? Can we go over one of those? I kind
Yeah.
of get strict on those, kind of. I don't know whenever it's a no solution or not.
Yeah, I mean, when we have absolute values, right? So let's say that we had the absolute value of x plus 5 equals -3. Well, when we take the absolute value of a number, we always get a positive answer. So in this case, there's not a way that we can ever end up with a negative number, right? And so if you have an absolute value equal a negative number, that will always be a no solution. Okay. However, when you're dealing with inequality statements, those are a little bit different, right? Because those aren't always going to be, if you have a negative on the one side, that isn't always going to mean that it's going to be a no solution on it. So like say that we have something like, let's see, the absolute value of x minus 3 is less than or equal to -1. So let's think about this, right? So again, on this one, if we're taking the absolute value of this, whatever it is, it's going to have to turn out to be a positive number, right? So I don't really care what number it is yet, but it has to be positive. And so I'm saying a positive number is less than or equal to, well, that's a negative number, right? Can a positive number ever be less than a negative number?
No.
No. So that would also be a no solution. I'm kind of put like a X through it just to make sure you see, like, positive numbers always have to be bigger than negative numbers, right?
Mm-hmm.
And so, does that help?
So just to make sure, if inside the absolute value is an addition, and then
No,
the number equals is subtract?
It doesn't
It's-
matter if this is a positive or a negative. The whole
Okay.
thing is going to end up being negative no matter what, or sorry, it's going to end up being positive no matter what, right? So let's say like that x equaled -7. So if I did -7 plus 5, that's -2, but I take the absolute value of it and I get +2. All right, so do you see I'll always end up with a positive number, and that doesn't work, right? I can't have a negative,
So it's
positive
the
number.
end result is negative.
Yes.
Okay.
Yep. So it doesn't matter, like the signs in between here, the add sign, right, or that subtract sign, that doesn't affect it. It's just, when you evaluate that whole left side, right, take the absolute value of that. That's always going to be positive, And then that number, -1, has to always be negative. So we can look at that and say no solution.
Okay, that makes more sense. Thank you.
Yeah, you bet.
So if on that one the sign was flipped, so if it was
Yeah.
the absolute value of x minus 3 is greater than or equal to -1, then you could solve for that.
Yeah, so let's look at this one. So if we were just using that same logic that we did here, right? The positive and negative, let's just look at that first. So this side is going to be what kind of a number? On the left side, what kind of a number will we have?
Positive.
Positive. And on the left, we'll have a negative. And so now we're saying a positive number is greater than or equal to a negative. When is that true?
Always.
Always. So when you have something like this, when it's always true, that's going to be all real numbers, -infinity to infinity. And you could solve it down and then check those answers and see that they don't work out, or sorry, that they do work out, and that everything, like if you graphed it, you'll see it's the whole number line is going to be what you have. So you could, still solve them kind of the same way we did here, but when it's an inequality, we'll put it on a number line and then look and see what that is. But if you have an absolute value greater than a negative number, that's always going to be -infinity to infinity. And it's just when we have an absolute value, like this one that we did, that is greater than a positive number, right, or less than a negative number, those you'll always be able to solve for and solve out. But on the one, and I'll tell you, there will be one on the test that's going to be kind of like these weird ones that we just talked about. And if you just explain to me, like if you even put down, like this positive and negative big business, or this is always true, this is never true, I don't even need to see any mathematical work. If you know that, then just write that down in words, and that's good enough for me to give you all the points. Is that clear?
Mm-hmm.
Okay.
Yes.
Those are really good questions. All right. Anything else? We're kind of wrapping up here.
For the exam, it's written, correct?
It is written, yep. So make
We
sure
take our scientific calculator.
Yep, scientific calculator. So it's going to be written out. So when you go into the testing center, they'll give you paper and to write it on. And I expect you to write all of your work that you want corrected right on that page. If you don't, they will give you scratch paper, but they're going to throw that scratch paper away. So I won't be able to give you any partial credit on it. So allow some scratch paper just in case you're like, I need to figure this out on another page. But anything you want me to correct needs to be written on the actual test. So show as much work as possible. Partial credit will be given. And that can really help out your grade a lot too, just by having partial credit. Okay.
And how soon after the exam will we have the results?
So I like to have them back to you within a week of getting them. So since the test is on Tuesday and Wednesday, I won't get them back until Thursday. And so that means I'll have them back to you before the following Thursday.
Okay, cool. Thank you.
Makes sense? Yeah. So I give myself a week to try and get those back to you, but hopefully I can get them back to you, sooner than that. So, okay. Awesome. Well, good luck. If you find that you have more questions as you're reviewing for the exam, great ways to review, again, are going through those, the past quizzes. If it was important enough to ask on a quiz, it could show up on an exam. Go through the reviews at the end of each module. Those would be great things to go through. And then there's an objectives review that you can find right in that exam 1 module. And if you go through those questions, they'll give you, questions that it would be good to study over for the exam as well. So a lot of different ways to practice and to get good at these and to be able to get ready for this test. Okay. All right. You guys are awesome. Thank you so much for coming, and make sure that you do that assignment for this. It's just 3 questions long, and I just make sure you follow the instructions on it so that you get all of the points on there. But like I said in my announcement to you, I just know that as students come to this or watch the recording, they tend to do so much better on the exam because you guys are kind of like learning everything from videos, and so this is your chance to actually ask a person, right? Or come to office hours because I love
we
it.
do have to write about this Zoom meeting.
Yes.
And submit?
Yep.
Okay.
Yep. So you'll see in the exam 1 module, there will be a thing that says attendance. So it's kind of like how I'm going to be taking attendance if you were able to attend this or not.
Okay, great.
Yep. Okay. You guys have a great night and reach out to me if you have questions. Okay.
Thank
Thank
you
you.
for your time.
You're so welcome.
Thank you.
Good night.
Thank you.
Bye.